We're in this incredible era of neuroscience. We have these tiny devices that can be implanted right into the brain to treat some of the most complex, most devastating disorders you can imagine, from severe depression to paralysis. These technologies are, and I mean this literally, changing people's lives.
And the people who volunteer for these experimental surgeries, they are absolute pioneers. So often, they're driven by this really powerful sense of altruism, this hope that, their personal risk might end up helping countless other people down the line. Take this quote from Brandy Ellis, a clinical trial participant. She said, "I believed that even if the device did not work for me, I might benefit others by participating." We're going to hear a lot more about her story in just a minute.
But this brings up a really critical and surprisingly complicated question. These volunteers are absolutely essential for science to move forward. But what happens to them when the clinical trial, the very thing that gave them this life-altering technology, just stops?
Okay, so to really get what's at stake here, let's start with the human story behind all this science.
So this is Brandy Ellis. Before she volunteered for this trial, she had gone through 25 different treatments for her severe treatment-resistant depression. 25! And nothing worked. So as a last resort, she had a deep brain stimulation device, a DBS device, implanted in her brain. And you know what? It worked. It totally gave her life back. Now, Brandy's story isn't just some one-off thing. She was a participant in this massive collaboration called the NIH Brain Initiative. It's this huge public-private effort to basically revolutionize our entire understanding of the human brain. And the knowledge we're gaining from pioneers like her is paving the way for some truly incredible new treatments.
But what happens when the amazing promise of these devices slams into a much more difficult reality? Let's take a look at what happens in that period right when the trial officially ends. And this gets us right to the heart of the issue, something called the post-trial period. You can think of it as a kind of limbo. The clinical trial is officially over, but the device, which is now a permanent part of the patient's body, hasn't actually been approved by regulators like the FDA. And this limbo, it can drag on for years. And look, just because the funding for a trial stops, a patient's needs don't just magically disappear, right? They still need access to the device that's keeping them healthy. They might need emergency care or software updates or hardware maintenance. They might even need more surgeries to repair something or just to replace a battery. And on top of all that, they need support, and they definitely need to know who's going to pay for all of it. So what you end up with is this incredibly stark contrast. It's like night and day. During the trial, everything is usually funded, it's structured, you have a whole research team supporting you. But after the trial ends, that entire safety net can just vanish. Care becomes a total free-for-all, responsibility gets murky, and the patient is often left to figure things out in this really stressful case-by-case negotiation. So why is this so hard to solve? Well, let's untangle this complex web of who is supposed to be responsible for what. The simple answer is there's no single person or group in charge. Instead, what you have is this tangled mess of different stakeholders. You've got the researchers, the device companies, the insurers, the government, and they all have their own roles, their own motivations, and their own very real limitations. This table really breaks down the gridlock perfectly. You've got small tech companies that might want to help, but they often just don't have the money. Some even go out of business. Then you have insurers who won't pay for something that's still considered experimental until they have proof it works for a lot of people. The government, they pretty much only cover FDA-approved devices. And the researchers who often have the closest relationship with the patients, well, their funding comes from grants, and those grants have very clear end dates. So basically, everyone's hands are tied. Just take the industry perspective for a second. Dr. Martha Morell from a company called NeuroPace points out that for a small innovative startup, the long-term costs of caring for even just a few of these patients can become, in her words, insoluble. It's a financial weight they just can't carry, and that can leave patients totally stranded. And for insurance companies, this is the key distinction. It honestly doesn't matter if the device was a miracle for one single patient. For them to cover it, they need huge amounts of data showing what they call general efficacy. A single success story, no matter how powerful, just isn't enough to write a new policy. Okay, so if the system itself is gridlocked, what's the fundamental ethical obligation here? What, at the absolute minimum, do we owe these research pioneers? Well, bioethicists have more or less reached a consensus on 3 minimum standards that should apply to any clinical trial. First, anticipate what a patient is going to need after the trial before you even start.
Second, be totally transparent with participants about what they can expect, including all the potential costs. And third, and this one is so important, make sure that any patients who clearly benefit from the treatment can continue to get it.
But here's the kicker. When we're talking about high-risk, life-altering brain implants, devices that literally become a part of who you are, the consensus is that the minimum is not nearly enough. Because the risks are so high and the dependency on the technology is lifelong, these participants are owed more. So if we all agree that there's a higher ethical duty here, how do we actually fulfill it? Let's explore some real, concrete ways to close these gaps in care. The central challenge really becomes this. How do we move away from this stressful patchwork system of last-minute negotiations and build a reliable safety net that actually protects every single one of these pioneers? Well, the good news is there are a lot of really smart solutions on the table. Experts have proposed things like creating a special trust fund to cover these costs, kind of like the one that exists for vaccine injuries. Other ideas include creating an orphan device designation for rare disease tech, requiring all grant applications to have a funded care plan built in, and maybe most important of all, actually giving patients a seat at the table when these devices are being reviewed. At the end of the day, this isn't just some abstract policy debate. This is about our collective responsibility. It's about what we as a society owe the people who are putting their bodies and their lives on the line so that science can move forward for all of us. Which really leaves us with this one last big thought. The BRAIN Initiative and projects like it are unlocking the deepest mysteries of human consciousness. And that's incredible. But the question we all have to answer is this. As we surge ahead into this amazing new frontier, how do we build a system that guarantees we don't leave its most important pioneers behind?